Now we're going to look at two other groups of properties, both of which we have talked about before, but not in a formal way. The first group are called the odd-even properties, and that just has to do with the fact that cosine is an even function. If we put opposite values for x, we get the same value for y. Sine and tangent are odd functions. If we put opposite values for x, we get opposite values for y for both sine and tangent. Now, when we talked about the definition of odd and even, we used the idea that with opposite inputs you get the same output. So in function notation, so I'm going to write down even here. In function notation it would look like this. F of negative x, the opposite of x, is the same as f of x. So opposite inputs give you the same output. Okay, f of negative x equals f of x. Opposite, the y values are the same even though the x values are different. For odd, we say f of negative x gives me negative f of x. Or in other words, if I put in the opposite of x, I get the opposite of y. Opposite input, opposite output. So we're just going to use that definition along with the fact that we recognize that cosine is an even function and sine and tangent are odd functions, and we are going to write the even and odd properties. So we can say that cosine of negative x equals cosine of x because cosine is an even function. We can say sine of negative x is equal to negative sine of x because sine is an odd function. And then we can say tangent of negative x equals negative tangent of x because tangent is also an odd function. Now, if you also wanted to talk about the reciprocal functions, the reciprocal of cosine would also, which is secant, would also be an even function, and the reciprocals of sine and tangent, cosecant and cotangent, would also be odd functions. So we could write the similar expressions for cosecant, secant, and cotangent. Our last group of properties that we're going to talk about in our basic group of properties are the cofunction properties. So recall, once again, we've got our same triangle. Sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x. But what if we looked at the angle over here? Okay, this is my right angle. So if this is 90 degrees and this is theta, there has to be another 90 degrees in this triangle, so this has to be 90 minus theta. So let's look at the trig ratios for sine, cosine, and tangent of 90 minus theta. Well, using this as my reference point, the opposite side would be x and the adjacent side would be y. So sine of 90 minus theta would be x over r. Cosine of 90 minus theta would be y over r, adjacent over hypotenuse. And tangent of 90 minus theta would be opposite over adjacent, which would be x over y. So notice what we have here with sine and cosine. We have some things that we can equate. We notice that sine of theta is the same as cosine of 90 minus theta. That's a property right there. We can say that sine of theta is equal to cosine of 90 minus theta. And vice versa. We can say cosine of theta is equal to sine of 90 minus theta. So there's our first pair of cofunctions. They are called cofunctions because their angles inside have to be complementary angles. They have to add up to 90 degrees. Now, what about tangent? There's no cofunction to go with it, or is there? Think about the fact that if tangent is y over x, then cotangent of theta would be x over y, the reciprocal. So that means cotangent of theta is equal to tangent of 90 minus theta. So cotangent of theta is equal to tangent of 90 minus theta. And vice versa, tangent of theta would equal cotangent of 90 minus theta. We could reverse that. Now it turns out there's one more pair of cofunctions, and that's secant and cosecant. So notice we have sine and cosine, tangent and cotangent. And our third one is secant and cosecant. So let's think about secant and cosecant. Okay, so secant of theta would be r over x. Cosecant of theta would be r over y. Secant of 90 minus theta would be r over y, and cosecant of 90 minus theta would be r over x. So notice what we can say. We can say cosecant and secant are cofunctions. Cosecant equals cosecant of theta equals secant of 90 minus theta. Secant of theta equals cosecant of 90 minus theta, because if we just take the reciprocal of these trig values, they have the same relation as sine and cosine have. So we can say secant of theta is equal to cosecant of 90 minus theta, and let's see, cosecant of theta is secant of 90 minus theta. Now, how would this look in radians? If we are in radians, this is the only property where we have to make a change here for actually being in radians, because we have this 90 degrees in here. In radians, we would just change 90 degrees to pi over 2, and we would have the same relationship. So let's check out this particular cofunction property on the calculator. So I'm just going to pick a couple of these to do. So I'm in radians now, so we'll do one with pi over 2. So let's say tangent of, I'll just be in radians. Let's say 4.5 radians. Okay, so there's tangent of 4.5. That's supposed to equal to cotangent of pi over 2 minus 4.5. So I'll put in pi divided by 2 minus 4.5. And they are exactly the same. Now let me switch to degrees. If I switch to degrees, let's do cosine and sine. So cosine of, what if I have an angle that's bigger than 90 degrees to start with? Okay, so let's say I have cosine of 192 degrees. How would that work with sine? Well, I'm going to do sine of 90 minus 192. Also a negative number. So cosine of 192 is in quadrant 3, where cosine is negative. Sine of 90 minus 192 ends up being sine of negative 100, also in quadrant 3, I believe. See, 90 minus, negative 100. Yep, those both end up being in quadrant 3 angles. But those are equal to each other. Okay, cosine of 92. So for example, if I have sine of, maybe, let's do cosecant and secant now. Secant of, let's put a negative angle in to start with. So negative 0.015. All right, there's a secant of that. Oops, that's such a small number, it's rounding to 1. Let me do a little bit different. Why don't we just say secant of negative 5.1. How about that? All right, close to 1. That's interesting. That's also close to 1. So if I do cosecant, I'm going to have to do 90 minus a negative 5.1. Okay. Now, 90 minus a negative 5.1 would be 95. So if I have a negative angle, then my other angle is going to end up being bigger than 90, or bigger than pi over 2 if I'm in radians. So we see that these properties really do work. So these are your, and I didn't put a box around all of these. I guess I can kind of box these up here. These are the first group of properties. And we're going to use these properties then to derive some properties that are particularly important for calculus.